Bismillahirrahmanirrahim. I'm Engineer Muhammad Suhaib, and today we will begin our new course, which is named as Engineering Mechanics, and we will discuss the lecture number 1 of this course, which is Introduction to Engineering Mechanics. In this lecture we will discuss some fundamental principles, some fundamental concepts of engineering mechanics. So stay tuned with this course, and let's begin with the lecture number 1. So the course objective of this course is that this course aims at enabling the civil engineering students to analyze various systems of forces and thereby be able to calculate the magnitude of these forces on various systems in statics and dynamics. So basically we will be doing two things in this course. First of all, we will analyze and we will explore the different kinds of forces which includes inside a system, and then we will study that what are the effects of these forces when they are in statics and when they are in dynamics, and what are the effects of these forces on different systems. What are the different kinds of effects, what are the different kinds of stresses, what different kinds of deformation these forces produce on different systems. So this is the whole idea of this course. The recommended books for this course are Engineering Mechanics by Merriam, Engineering Mechanics by Hibbeler, and Engineering Mechanics by F.L. Singer. I would recommend that you have to study the Engineering Mechanics by R.C. Hibbeler because it includes so many examples and the graphics of these books are also very good. The contents of today's lecture are, first of all, we will discuss some basics of mechanics, then we will explore the branches of mechanics. After this, we will discuss engineering mechanics and different branches of engineering mechanics, and then we will discuss some basic terminologies, some basic principles of engineering mechanics. So let's start with the basic definition of mechanics. So mechanics is the branch of science which deals with the effect of forces on bodies. So basically in mechanics we study two things. First of all, we study forces, that what are the different kinds of forces that are present in a system, and what are the effect of these forces on the bodies which are inside a system. So let's say, for example, we have this kind of system in which we have two cables and a mass of 2 kg have been attached to these two cables. Now if you want to study that what is the effect of the forces which are produced in these two cables because of the mass of 2 kg. So the forces which are induced in these cables are T1 and T2, which are actually tension forces, tensile forces, and the effect which produce in this stress are tensile stresses. So in mechanics we will study what are the forces, that is T1 and T2. What are the forces that the mass produces in these cables, that is T1 and T2, and what is the effect of these forces on this cable. So if you want to study that what is the effect of 2 kg mass on attached cables, so cables are actually body and mass actually produces forces in these cables. So in the mechanics will answer these two questions, that what are the forces and what are the effects of the forces on the body. Similarly, if you want to explore the effect of 800 Newton reaction, this is the 800 Newton reaction, which is a force on the tendon. This is the tendon. If you want to study that what is the effect of this reactive forces, of this reactive force 800 Newton on this tendon, so mechanics will answer this question. Similarly, if you want to discuss that what is the effect of force on a rod, this is a rod, a metallic rod, and rod is actually a body of length L. So if you want to study that if we apply a force of F on this rod in this direction, as you can see in the horizontal direction in along the x-axis, then what will be the effect of the force on this body or on the length of this body. Then we will study all of these things in the branch of mechanics. Okay, so mechanics is further subdivided into three parts: rigid bodies mechanics, deformable body mechanics, and fluid mechanics. So actually matter exists in three states: solid, liquid, and gases. Solids are discussed in the branch of rigid bodies and deformable bodies, while the liquid and gases are discussed in the branch of fluid mechanics, because liquid and gases are called fluids. Actually, solids can be deformable, they can be non-deformable. If they are non-deformable, then they are known as rigid bodies. If they are deformable, they are known as deformable bodies. So rigid bodies are discussed inside the engineering mechanics, while the deformable bodies are discussed inside the solid mechanics, which is also known as mechanics of solids. So let's define that what is a rigid body. Any body which does not undergo deformation, a change in length or change in area or in change in shape under the action of forces is said to be rigid. So the definition of rigid is that the rigid body does not go any deformation, there does not go any changes in any dimension, either in length, either in area, or either in shape or volume. And this deformation is actually measured with respect to or relative to a system. For example, this is a whole system which includes a truck and a crane. Now the boom of the crane is the length of the boom of the crane is very large, and if we consider the deformation in this boom as compared to its length, that this deformation is very small, that it can be neglected. So we can assume this, or we can idealize this boom as a rigid body. But if we are analyzing very small objects whose length is very small, then the deformation will be relatively very high, and we cannot ignore these deformations. So those kinds of bodies will be called as deformable bodies, and they will be discussed in the branch of deformable body mechanics. Deformable bodies deals with how forces are distributed sorry, that how forces are distributed inside bodies, and with the deformation caused by these internal forces distributions. These internal forces produces stresses in the body, which could ultimately result in the failure of material itself. We will discuss all these concepts, all these things in detail in the coming slides, in the coming lectures. So for now, just you have to understand these things, the deformable and deformable bodies. We actually in deformable bodies, we actually consider the deformation in the system, but in rigid bodies we don't consider the deformation in the system. In rigid body mechanics, we assume that there are no any deformation in the system. In deformable body mechanics, we assume, or we consider all the deformations that occurred inside a system, and all the stresses there, they are linked with the deformation in a system. And the deformable body mechanics is also known as mechanics of solids. Here you can see that in rigid body mechanics, we don't include, or we don't consider any kind of deformation inside the system, while in deformable body mechanics we include the deformation, that what are the deformation occurring inside the system, and what are the stresses that are induced because of these deformations. So now the third branch of engineering of mechanics is fluid mechanics. The fluid mechanics is the branch of mechanics that deals with liquids or gases, because liquids or gases are collectively known as fluids. It studies the movement of fluids, their interaction with solid boundaries, and how they respond to various forces and pressure. So actually fluids are always bounded inside a boundary, inside a closed boundary, inside an open boundary, but a solid boundary is always there to contain a liquid. Now the fluid which is contained inside a liquid, inside a boundary or inside a system, it exerts some forces on the boundaries. So in fluid mechanics, we actually examine what are the different kinds of forces that exert the fluid on the boundaries, and what are the stresses that are produced because of the fluids. And we discuss all these stresses, all these forces inside the fluid mechanics. The engineering mechanics, which is the rigid body mechanics, is actually divided into two parts, subdivided into two parts. First one is statics, and second one is in dynamics. And the dynamics is again divided into kinetics and kinematics. So let's discuss them in a little bit detail. So statics, it is the branch of engineering mechanics which deal with the forces and their effects while acting upon the bodies at rest or moving with constant velocity. So in statics, we only discuss those kinds of systems or those kinds of materials in which the system or the body is at rest and force is applied on the body, and then what are the effects of the forces which produce in the body which is at rest. Or we also discuss those kinds of bodies which are moving with a constant velocity. So those bodies which are moving with a constant velocity, and if we apply a forces on these bodies, then what will be the different kinds of effects that are produced in these kinds of forces who are moving with constant velocity. So all of these systems or all of these bodies are studied inside the statics. In dynamics, actually, it is the branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. So when a body or a system is moving, and if we apply a force on that body, then what are the different kinds of effects that are produced in these bodies which is actually moving. So this kind of system or this kinds of forces are actually studied inside the dynamics. While in kinetics is the branch of mechanics which deals with the motion parameters as well as forces responsible for the motion. So actually in dynamics, what we study that there is a body which is moving, and there are some kinds of forces which are produced in the body when when this is moving, or if we apply some kind of forces on the body which are moving. So in kinetics, we actually describe, or we actually explain, or we actually analyze the forces which are produced inside the body and the motion which are induces the forces inside the body. So we study both of the things, the motion and the forces as well. While in kinematics, it is the branch of mechanics which deal with the motion parameters without considering the forces responsible for the motion. So in kinematics, we actually study the motion only. We don't consider the forces. We consider only the motion which is produced inside the body. For example, let's say if we consider a person who is moving. So in kinetics, we explain both the motion of the body and the force of the body which produces the motion inside the body. But in kinematics, we actually explain that we actually study the motion, and we don't consider the force, that okay, whatever the force it will be, we have to study only the motion of the body. So this is the difference between the kinetics and kinematics, and both of these are studied inside the dynamics. Now let's discuss some basic terminologies. So the first one is space. Space is a geometric region occupied by bodies whose position are described by linear and angular measurements relative to a coordinate system. For three-dimensional problems, 3 independent coordinates are needed. For two-dimensional problems, only 2 coordinates are required. So space is actually a geometric region in which we have to locate the position of a body. For example, P is a body. Let's say P is a body, and we have to locate the position. So we have to locate its position with respect to some reference points, or with respect to some reference planes, or with respect to some reference lines. In case of two dimension, the reference lines are two. One is x-axis and other one is y-axis, and we have to look at the relative position of this body with respect to this x-axis and with respect to this y-axis. And we can do it if we have the coordinates of this body as x and y. If we have the coordinate x, which is the position of the body with respect to x-axis, and if we have the coordinate y, which is the position of the body with respect to y-axis, then we can locate the body inside a two-dimensional space. But if we want to locate the body in a three-dimensional space, then we will be required another dimension, which is the z-axis, which is the elevation actually. So we have to give 3 dimension, the x dimension, y dimension, and z dimension, and then we can locate this point in the space. So in 3 dimension, we actually require 3 coordinates, while in 2 dimension we require 2 coordinates, and it depends on the system. Other term which is very important is the time. It is not that much important in statics, because in statics we don't consider any kind of time, while in dynamics we consider time, and we have to analyze the time, that what are the duration of the forces which is acting on the body. So time is conceived as succession of events. Although the principles of statics are time independent, this quantity plays an important role in the study of dynamics. Another term which is very important in mechanics is the mass. So the quantity of matter possessed by a body is called mass. The mass of a body will not change unless the body is damaged and part of it is physically separated. So any quantity of matter which is occupied by any thing or any body, this is termed as mass. And the mass of body cannot be changed either on Earth, either in space, either on another planet, until and unless some part of the body is damaged or it is detached. Unless and until, the mass will remain same anywhere. Another term which is important in dynamics is particle. A particle is an object whose mass is considered at a point. For this reason, a particle is also called a point mass, and it's said to have zero volume. Now in practical, there is no body, or it is impossible that a body which is having zero volume. But we consider the zero volume in such cases if we are analyzing a very large system, and the volume of the body is very small as compared to the system. Then we can consider the volume is to be negligible, and we can consider it as a point mass. For example, if we analyze a system, if we are analyzing a system on the Earth's atmosphere, then the volume of an atom, or volume of an electron, or volume of a proton is very small as compared to the system. Then we can neglect the volume of the particle, and we can assume it as a point mass. But if we are analyzing a solar system, in a solar system, or if we are analyzing a galaxy, or if we are analyzing a system in space, then in space the volume of the earth is very very small as compared to the other planets. Then we can consider the earth as a body which is having zero volume, or which is having a negligible volume, and we can consider earth as a point mass in this kind of systems. Now, some basic principles of engineering mechanics are the Newton's three laws of motion. Actually, the engineering mechanics is formulated based on Newton's three laws of motion. The first law of motion states that every body continues to its state of rest or of uniform motion unless or until some external forces acts on it. So it is a very basic concept, and I think all of you will understand that Newton's first law of motion explains that any body which is at rest will remain at rest, and any body which is moving with a constant velocity will be moving in a constant velocity, and this state of the body is actually known as equilibrium. If we apply some external forces which disturb its state of rest, or which disturb its motion in a constant velocity, then the body will not be in equilibrium anymore, and the system will not be in equilibrium, and the Newton's first law of motion will not be applicable in these kinds of systems. Newton's second law of motion states that a particle acted upon by an unbalanced force F experiences an acceleration A that has the same direction as the force and a magnitude that is directly proportional to the force. So Newton's second law of motion states that, let's say there is a body, and if we apply a force along the x-axis, then the acceleration produced in the body will be also in the x-axis, and the relation between the acceleration and the force will be given by this equation, which is F is equal to ma. Newton's third law of motion states that the forces of action and reaction between bodies in contact are equal in magnitude, opposite in direction, and collinear. It means that they have the same line of action. So according to Newton's third law of motion, if a force is applied in a direction, like let's say this force is applied in the x-axis, which is in the negative x-axis, the direction of this force is the negative x-axis, then an equal and opposite force is produced in the opposite direction, and these two forces are collinear. The line of action of these forces is the same, and these forces are equal in magnitude but opposite in direction, and this is actually the concept of Newton's third law of motion. Now let's define that what actually a force is. Force may be defined as any action that tends to change the state of rest or motion of a body to which it is applied. So actually, whenever a force is applied, or whenever if we say that there is a force acting on the body, so this force will tend, or it will changes the state of the body. If a body is at rest, it will make it in motion, or if a body is moving with a constant velocity, then it will change its velocity and it will produce some acceleration in the body. So anything which produces an acceleration in the body, or anything which makes a body which is at rest to motion, then this action will be known as force. This will be termed as force. Now the force will be having three characteristics. The first characteristic is the magnitude. That what is the magnitude of the force? What is the amount of the force? It is a 10 kilonewton, 20 kilonewton, 30 kilonewton force. And a second one is what is the direction of the force? That in which direction the force is actually acting. And the third one, that what is the application point of application of the force, that at what point the force is actually acting. So if we want to analyze the force inside a system, we have to check the three things. First one is the magnitude, at what is the magnitude of the force. Second one, in which direction the force is actually acting. And the third one is what is the point of application of the force on the system or on the body. Forces can be body forces, they can be surface forces. Body forces are also known as non-contact forces because for the application of such forces, contact between the surface is not essential. For example, gravitational force, magnetic force, electric force, etc. Surface forces are also known as contact forces because for the application of this type of force, contact between the surface is necessary. For example, friction force, reaction force of the roller, and head support, etc. etc. Forces can be concentrated force, they can be distributed forces. For example, let's consider this beam, the beam AD, which is supported on a hinge and on a roller. We will discuss the support condition in detail in the coming lectures, but this is a hinge support, this is a roller support, and a beam is actually supported on these two supports, A and D. And let's say there are two persons, P1 and P2, who are standing at position B and position C. Now the load or the force or the weight of the person 1 and the person 2 can be assumed or can be considered as a point force acting on the point B and on the point C, and they are actually known as point loads, point forces, or concentrated loads. Or in the second example, if we consider the beam AC, which is supported on a pin and on a hinge, and there are certain of people's number of people acting as sitting or standing on the beam, then we cannot consider the forces as to be concentrated forces either. Rather, we will consider these forces as distributed forces, which are equally distributed on the beam AC. We will discuss these kinds of forces in detail in the coming lectures, inshallah. The forces can be external forces, they can be internal forces. For example, for the bracket in the figure 2.1, this is the figure 2.1, the effect of P, this is a force which is a tensile force which is produced inside the body, and this force actually is acting externally on this bracket. So the effect of P external to the bracket are the reactive forces not shown exerted on the bracket by the foundation and the bolts because of the action of P. Forces external to a body can be either applied forces or reactive forces. So the forces which are actually acting on a body, which are external, they can be applied forces. For example, if we are applying some force, or they can be reactive forces. If we are applying some force on a body and the body or the supports reacts to these forces, and the support produces some reactive forces to the system, these two kinds of forces will be termed as external forces. Okay, so internal forces are actually these are the forces which are produced inside a body. For example, if we apply some kind of force on this bracket and we want to analyze it, what are the internal forces or internal deformation that are produced inside the bracket, then we have to take a section of this bracket and then we have to analyze that what are the different kinds of forces that are produced inside the body, what are the different kind of stresses, what are the different kind of deformations that are produced inside the body. So for this we have to analyze the internal forces which are produced inside the bracket. So the forces can be internal as well, and the internal forces are also discussed inside the mechanics. The internal forces can produce different kinds of stresses in the body. They can be tensile stresses, they can be compressive stresses, they can be bending stresses, or they can produce bending, they can produce torsion, and they can produce shearing. If the forces try to pull an object, for example, this is an object and the force is applied in this direction and in this direction, then it will pull the object in these two directions. And if it elongates the object, then these forces will be known as tensile forces, and the stresses which are produced in this body will be termed as tensile stresses. Now if the forces actually pushes the body and the forces are applied in this direction and in this direction, and it actually pushes the body, it contracts the body, so these kinds of forces will be termed as compressive forces, and the stresses which are produced inside the body will be termed as compressive stresses. Now if a body produces bending or they produces rotation inside a body, for example this force is acting in this direction and it produces the bending in the body in this direction, here you can see my cursor, then these kinds of stresses are known as bending stresses and the forces are known as bending. If a body produces twisting in a body, this is a force which is acting in this direction, actually it produces torque in the body, and this force is produced in this direction, these two have opposite direction, so it will produce twisting in the body, and the forces and the stresses which will be produced in this body will be termed as torsion. And if the body produces shearing or they produces tear in the body, for example this force is acting in the upward direction, this force is acting in the downward direction, and at this location shearing will be produced, tearing will be produced, and the body will be broken down. So these kinds of forces are known as shear forces, and the stresses which are produced on the surface of this body will be termed as shear forces. and we will discuss these all kinds of forces in detail in the engineering mechanics, in the mechanics of solid, in the structural analysis, and other courses as well. Okay, so far we have discussed forces in details, but in mechanics or engineering we actually discuss another term which is known as load. So load is actually a specific force which is acting on a body, and we have to analyze the system for these specific forces, for these specific kinds of reactions, or these specific kinds of forces which is acting on the body. So those specific forces which are acting on the body, and we have to analyze the system for these specific forces that are termed as loads. So load is a term frequently used in engineering to mean the force exerted on a surface or a body. The load can be live loads, they can be dead loads, they can be snow loads, they can be wind loads, they can be lateral forces or lateral loads, they can be hydrostatic pressure or hydrostatic loads. So the dead loads, they are vertical loads, they can be horizontal as well. Vertical loads that are fixed in a position and that are produced by the weight of the elements of the structure or the whole structure with all its permanent components. So any component which is permanent and which is cannot be detached from the system, for example the roof, for example the wall, for example the floor, for example the slab, these are all the components which cannot be detached from the system. So they produce a permanent load, or a load which cannot be removed from the system whenever it is constructed. Whenever it is constructed, then these kinds of forces are known as dead loads. While in contrast, live loads consist mainly of occupancy loads, for example people, air, furniture in buildings, and traffic loads on bridges. They may be either fully or partially in place or not present at all, and may also change in location. For example, let's say this building is a school building, okay, and there are 50 students, and the school is actually designed for the occupancy of 50 students. Now the load of the 50 students is actually live load, and when we are designing the building, we have to take a load of 50 students, but it is not possible that at any time all of the 50 students will be present. It is possible, but most of the time maybe 38 students are present, 40 students are present, 45 students are present, and they will be present in the school time and in the weekdays. On the holidays and in the afternoon and at the night, there will be no any student inside the building. So at night there will be no any live load in the school, but in the daytime and in the weekends and the weekdays, there will be live loads of 50 students on the body. So these loads of the students will be termed as live load. Similarly, the load of traffic or the vehicles on the bridges or on the roads is also a live load, because a car is always moving on a road, it is not always standing on a road. So the load or the force or the weight of the car is also termed as live loads. Okay, then we can have seismic loads. So seismic loads are actually the loads which are produced, or the forces which are produced because of the earthquake. So if the earthquake in the x direction, the force will be produced in x direction but opposite to the motion of the earthquake. And if the earthquake is in the y direction, the forces will be produced in the y direction but it will be in the opposite direction. And all of these forces are termed as seismic loads or seismic forces. And we will discuss all of these forces in the course of structural dynamics. Other than that, we can have snow loads which are produced because of the snow. We can have wind loads which are produced because of the wind. We can have lateral forces because of the because of the soil, which is acting upon the house or the building. And we can have hydrostatic forces which are produced because of the water. So the property of the lateral forces of the soil and of the water are the same, because the magnitude of the stresses or magnitude of the pressure are increases with respect to the depth. As we go deeper, the stresses inside the stresses on the body actually increase. The loads can be thermal loads, which are produced because of the shrinkage occurs inside a body because of the temperature, the changes in temperature. So in summer, the bodies or the matters are actually elongated, while in winter they are contracted. So this expansion and this contraction actually produces stresses in the body, and these stresses are termed as thermal stresses. Other than that, we can have settlement loads. For example, there is a building and it is supported on its foundation, and the soil which is beneath the foundation is not that stable and it settles down. So the differential settlement will be occurred in the body, and one side of the building will be settled down and while the other side will be not settled, and this settlement will produce some deformation in the building and it will produce stresses in the building. So these kind of stresses are known as settlement loads or settlement stresses. Now we have discussed forces and we have discussed loads. So the other term which is corresponding to these forces and these loads are stresses. So stress is a term used to express the internal force or resistance offered by a particle to the adjacent particle in a body under the action of external loads. So stress is the internal resistance per unit time. For example, if a force of F is applied on a cross-sectional area of A, then the force will be produce a stress on the whole cross-section of area A. These stresses can be normal stresses, they can be shear stresses. The normal stresses can be tensile stresses, or they can be compressive stress. Now let's discuss the force system. Force system can be non-coplanar or they can be coplanar. Coplanar, it means that all the forces acting in a same plane, while non-coplanar means that all the forces are not acting in the same plane while they are acting in the different planes. Non-coplanar forces can be concurrent, they can be parallel, they can be non-concurrent and non-parallel. While the coplanar forces, they can be collinear, they can be concurrent, they can be parallel, or they can be non-concurrent and non-parallel. For example, let's see these forces, these P forces are actually collinear. The line of action of these two forces is the same, so they are termed as collinear forces. Here we can see that we have four forces, P1, P2, P3 and P4, and all of these forces are concurrent forces because the line of action of all of these forces are passing through a common point. In this example, we can see that all the forces are parallel. They are opposite in direction. The R1 and R2 have the same direction, while the P1, P2 and P3 have the same direction, but the direction of P1, P2 and P3 is opposite to the direction of R1 and R2. So the line of action of these forces cannot be intersected at any point, so they are termed as parallel forces. And this is the best example of non-concurrent and non-parallel forces. Here you can see that the direction of R is in upward direction, W is in downward direction, and W and R are actually parallel forces. But P2 and R are not parallel forces, while P1 is also not parallel to either P2 or either R or either W, and the line of action are not passing through a same point, so they are non-concurrent and non-parallel forces. Now let's discuss the principle of transmissibility, which is a very important principle, and we will be using this principle throughout the course of mechanics. So this principle states that a force may be applied at any point on its given line of action without altering the resultant force, the resultant effect of the force external to the rigid body on which it acts. So we can do we can move the forces along its line of action from one point to another point, but we have to confirm that the resultant effect of the force is not disturbed. For example, there is a force P acting on point A or acting on point B, let's say, and this force is acting on this point and in this direction. But if we move the force P from this point B to this point A, and it is acting on the same body and it is acting in the same direction, and it does not produce and it does not affect the resultant effects of the force on the body, because there is a hinge and this force cannot move the body in this direction. If we apply this force on point B or on point A, it does not change the effect of these forces, so we can say that okay, if it is applied on point A or if it is applied on point B, it will be the same and it will produce the same effect in these two points. So we can analyze the system either with respect to point A or either with respect to point B. All of these concepts will be explained in the coming lectures, and it will be cleared as we move on with the course. Now some fundamental quantities of mechanics are the length, mass, force and time. These are the four fundamental quantities, and we have to study all of these quantities inside the course. The common units for length in MK system are meter, centimeter, and millimeter. When we analyzing a whole system, a whole building, then we consider the unit of meter. And if we consider deformations, or if we are analyzing very small system, then we have to take the units of millimeters. In FPA system, the unit can be mile, it can be foot, and it can be inches. If we are analyzing some roads, then we have to use the unit of mile. And if we analyzing some buildings and some beams or columns or very small objects, then we have to use the system of foot and inches. The common unit of masses are ton in MK system. They can be ton, they can be kilogram, they can be gram, and they are actually expressed relatively. For example, if we are analyzing a system in which we have to calculate the quantity of reinforcement, then we have to use the unit of ton. But if we are consider some small quantities, then we have to use the unit of kilogram and gram. In FPA system, we use slug, we use pounds, and we use ounce. You have to confirm that pounds cannot be changed with the pound force, because pound is same for the mass and for the weight as well. And if mechanics, we use pounds. In engineering mechanics, we use pounds for forces, while in the structural dynamics, we use pounds for the masses, so they cannot be confused with each other. The common units for forces are in MK system, they are Newton, kilonewton, and meganewton, while in FPA system, as I have discussed in previous slide, they can be pound force and they can be kilopounds, which is also known as kips. The pound force is actually abbreviated by LBF, so that it cannot be confused with the mass pound. The common unit of time are seconds, minutes, and hours, and they are same throughout the MK system and FPA system. Okay, so that was all for the lecture number 1. If you guys have any kind of questions or any kinds of confusions, so you can ask in the comment section, or you can email to me personally. I will answer all of your questions, and we will discuss all of these all of these terminologies, all of these principles in detail in the coming lectures. Because this was a starting and it was an introductory lecture, that's why we have only defined the terms, different terminologies, and we will explain all of these principles in detail in the coming lectures. So thank you so much for watching this lecture.